Hey everyone, welcome to this explainer. We're jumping right into a highly practical masterclass today where we're going to tackle something absolutely amazing. We are going to build a working artificial intelligence model in exactly 30 minutes. And honestly, the best part, it's going to cost you literally $0 and you won't need to write a single line of code. So if you've ever felt kind of intimidated by AI, consider this your personal gateway. Let's get to it.
Okay, let's dive into this. Here is our central challenge. Imagine you've got 5 everyday things sitting in a kitchen, right? Haldi or turmeric, lal mirch or red chili powder, jeera or cumin, chawal, which is rice, and chana dal, a yellow lentil. Now, can a computer, specifically just using the camera on that phone in your pocket, instantly and accurately tell these 5 unlabeled containers apart? I know, it sounds like some massive, expensive corporate tech problem, but we're going to solve it together today.
To get there, we've structured this explainer into 5 quick chapters: the AI coding myth, rules versus examples, the gather, train, and export pipeline, beware spurious correlations, and finally, the value of honest failure.
Starting with Chapter 1, the AI coding myth and why anyone can build AI.
You know, for way too long, people thought you needed a PhD in math or fluency in crazy complex programming languages like Python just to touch artificial intelligence. Well, we're going to completely destroy that myth right now. The tool we're using today is Google's Teachable Machine. It runs entirely right in your web browser, Chrome, Safari, whatever you use, and it's powered by a library called TensorFlow.js. It's 100% free, requires 0 coding skills, and maybe most importantly, it's completely private. When you point your phone at your kitchen counter, those photos do not get sent off to Google's servers. The whole training process happens locally, right there on your device. It's a real, actual neural network running privately in a browser tab.
Moving on to Chapter 2, Rules versus Examples, which is really a total paradigm shift.
Before we even open the tool, we need a quick mental shift. To get this, we have to fundamentally change how we think about teaching computers. The old way of programming? It was entirely rules-based. A human had to sit down and handwrite rigid instructions like, hey, if the color is yellow and the texture is powder, then it's haldi. But what happens when the lighting changes, right? Yellow at high noon looks totally different than yellow at midnight under a dim bulb. Boom, your rigid rules break. The new way, machine learning, uses examples. You just show the computer 50 photos and say, these are haldi. The computer figures out the rules and the patterns entirely by itself. It's adaptable.
Let's move to and see how this builds into our next section. Chapter 3, Gather, Train, and Export, the Machine Learning Pipeline.
Every single machine learning project in the world, whether it's the fraud detection system at your bank, a multi-million-dollar robotics project at Augurio, or our simple Masala sorter, uses this exact same foundational pipeline. It boils down to 3 totally unintimidating steps. Step 1, gather. You just collect your example photos. Step 2, train. You literally hit a button and let the computer find the hidden patterns in those photos. And step 3, export. You take that trained model and put it somewhere useful, like a shareable web link. Gather, train, export. That's the whole shebang.
But the secret sauce is really in how you gather those examples. So here are the 4 rules for good data. Number 1, use a boring background. Otherwise, the AI is going to learn your table pattern instead of the actual object. 2, keep the camera about 1 hand span away, so it's consistent. 3, move the object around. Rotate it, tilt it, shift it. You want varied photos, not identical ones. And 4, mix up your lighting. Use window light, use room light. Always remember, 80 varied dynamic photos are vastly superior to 500 identical ones.
Speaking of numbers, let's talk about the exact breakdown. Under 30 samples? Yeah, that won't work reliably. 50 is your bare minimum. But 100 to 150 photos? Now that is the absolute sweet spot. You really want to aim here. Especially because we're asking the AI to differentiate between some pretty tricky visual twins. Think about haldi and chana dal. They're both yellow. The model is going to need enough examples to really notice the powdery texture of the haldi versus the chunky texture of the dal.
And here is the absolute most common beginner mistake. You have to include a negative class. Let's call it kali, meaning empty. Think about it. If you only teach the AI what 5 spices look like, it's forced to pick one of those 5 options at all times. So if you point your camera at an empty table, it might super confidently tell you it's looking at rice. No way. You must teach the machine what an empty space looks like so it knows exactly when to just say none of the above.
Which brings us to Chapter 4, Beware Spurious Correlations, or what happens when AI learns the wrong clue.
Now, what's really interesting about this slide is that once you train your model, you test it. And this is usually where we hit our first major roadblock. Honestly, this is where the real learning happens, because we have to talk about what happens when your AI gets lazy. Spurious correlations happen when the model learns a clue that just happens to be in the photo, but isn't actually the subject at all. For example, if you photograph your yellow haldi on a dark, heavily patterned tablecloth, the AI might think, dark cloth plus yellow equals haldi. So if you later put that exact same haldi on a plain white table, the AI fails. It literally learned your furniture, not your spice.
And hey, if you think this is just a rookie mistake, get a load of this real-world example. A massive, multi-million-dollar medical AI system was actually trained to detect skin cancer. But when they rolled it out, it failed miserably in the real world. Why? Because in the training photos, doctors had placed a little medical ruler next to the cancerous tumors for scale. The AI didn't actually learn what cancer looked like, it just learned to spot a ruler. So yeah, spurious correlations affect literally everyone.
That leads us straight into our final section. Chapter 5, the value of honest failure in upgrading from a demo to a tool.
When your AI fails, and trust me, it absolutely will, you shouldn't see it as a bug. We really need to reframe how we look at mistakes here, because anyone can get a 99% accuracy score by testing their model on the exact same photos they trained it on. But that's just version 1. It's a fragile demo. Version 2 becomes a robust, actual tool because you actively went looking for failures. An engineer who knows and clearly states the exact limits of their system is vastly more trustworthy than one who tries to hide them.
Once you've broken your model, fixed it up with better data, and made it truly robust, it's time to set it free from the browser. The tool offers 3 main export options. TensorFlow.js gives you a simple web link you can just text to a friend so they can use it on their phone instantly. Standard TensorFlow is geared towards Python developers on a PC, and TensorFlow Lite is perfect for mobile apps, physical hardware like a Raspberry Pi, or even integrating into an Augie Robo robot. Now, as I mentioned at the start, this is a masterclass, which means you've got an assignment. Because just watching isn't learning, actually doing is learning. Level 1 is to just rebuild the Masala sorter exactly as we discussed. Level 2, make it yours. Go solve a problem in your own house. Sort family medicine strips, identify coins, separate wet waste from dry. Level 3, intentionally break it 4 different ways and document exactly how you fixed it. And finally, level 4, find one case where your best model still fails and figure out why.
So the crucial point is captured perfectly in this mindset right here. The failures are not problems. The failures are your next data set. This is absolutely the fundamental attitude required to build reliable AI. Every single time the model guesses wrong, it's not failing. It's just telling you exactly what kind of photos it needs to see next.
You now have the knowledge to build a working, private, highly capable artificial intelligence model right in your browser for free, without a single line of code. The tools are completely democratized now, and literally the only limit is your creativity. So look around your home, look at your daily routines, and ask yourself, what everyday problem are you going to solve with your new AI skills today? Get out there and start building.